morning, my name is Adam Adame. As a part of the project, I represent a technology partner, Tauron Polska Energia from Poland. Today, I would like to tell you more information about adaptation to climate change in energy sector. I think it might be interesting for you because of our study topic. First is energy efficiency. An example of increasing energy efficiency is the thermal modernization of buildings. Why? It's adaptation to climate change. Thermal modernization saves energy, which means that less energy is used to meet the needs of the building, which leads us to the less carbon dioxide emissions. This is an action that indirectly improves the quality of environment and the quality of air. It's also a good example of how to consider the topic of adaptation to climate change. You need to think very widely, take into account the indirect or long-term effects, not only what is fast and simply to do. Another, more obvious example is development of renewable energy sources. The development of renewable energy sources has been implemented for years using wind and photovoltaic technologies. Renewable energy sources work depending on weather conditions. Therefore, it is important to combine them into a system ensuring greater work efficiency. Renewable energy sources are not only wind and solar farms. There are also biomass sources or hydroelectric power plants. But because of case study, I would like to focus on wind and solar technologies, which are also the most popular of them, and I'm sure that all of you have seen them more than once in your life. What is also important development of offshore wind turbines or wind farms. In recent years, there has been a dynamic development of offshore technologies. Offshore technologies mean wind farms installed on the water, not on the ground. Onshore farms are on the ground. And it's important that these offshore wind turbines usually has higher powers, are much bigger devices with much more power. Of course, windmills of this type can have larger size and greater power than typical onshore turbines. But what is more important, there are also good working conditions for this installation at the sea. For example, there are no objects that reduce wind speed. It means that wind turbine on the ground has worse conditions to work because, for example, buildings, trees, or other objects could lower the wind speed. And the wind turbine in this situation cannot use its full power. But at the sea, there are no objects like that. So these wind turbines might work with greater efficiency and produce more energy in less time. Another interesting topic is distributed energy. It might be considered as the effect of increasing public awareness. In addition to the development of large renewable energy sources, the number of domestic renewable energy sources installation is growing really dynamically. The number of prosumer installations is growing really fast. At some point, it might happen that the owners of installation located close to each other would like to manage their installation together. This trend creates new challenges and at the same time creates new opportunities. Attempts to connect this small installation into larger system. And I'm sure you could find a lot of domestic installation around your neighborhood. It's right now really popular technology, and it's something what we could see in our daily life almost every day. But how to combine them into larger system? There are few technologies that might be taken into account, but today we would like to focus only on one of them. We would focus on microgrids. Microgrids. What are microgrids? So, microgrids is physically separated area covering local energy sources, mainly renewable, and consumers of energy produced from these sources. Energy storage and gas or oil generators are also built into microgrids, which provide energy in situation of insufficient production of energy from renewable energy sources. All elements of the microgrid are connected by a power network, and the work of them is controlled by an IT system. So in microgrid, a lot of renewable energy sources of different type might work together as a one installation, and it's possible because of energy storage and also because of IT system that control work of this installation. And you could see this on this picture. You have your wind turbines, you have some domestic installation, you have some storage. This storage is these white blocks on the picture. You can also find here some photovoltaic installation and some consumers of energy, so hospital, some buildings like here on the right, some electric car, and also some industrial consumers. Here is some manufacturer or something like that. And in the center of all of it, there is an IT system which controls microgrid like a one installation. On the next lecture, you will find much more information about microgrid, because one lecture focused only about microgrid. But right now, it's important for you to remember that microgrid is one of great example of adaptation to climate change, because it could combine few different renewable technologies into one larger system. And it's all for this lecture. I hope it was interesting for you, and of course you will find more information about it in the future presentation. Thanks for your attention.